Hello everybody. Today we're going to learn about lists. Lists is a very important topic in Python and they are normally used to store several variables in one variable itself. For example, if I have a variable, let's say 500, and I have another variable, let's say 200, I have a third variable 300. Now let's say I want to find the average of these three variables. What I do is print a plus b plus c and this divided by 3. That's what average does. However, instead of creating three variables, what I can do is I create a list L. Now I open square brackets to tell Python that hey Python, I want to declare a list right now, and I declare whatever I want in the list: 500, 200, 300. It's all separated by a comma, and there you have it. All these three variables are now stored in one entire variable called L. I can print L also and see what happens. I get the average over here. What happens over here is I have to do a comma b comma c if I want to print the 3, and I get it like this. In other ways, I declare it in one and I can print it itself, and Python will return it to me. However, now a good advantage of lists in Python is that, which is not available in other languages, is the feature of storing different data types in the same list. I can store a string as well, I can store a boolean as well, and integers are already there. And if you see, if I remove this thing, everything has been run out and I can get it exactly as it is, even though I have an integer over here and a string over here. In other languages, if you have an array or a list, it has to be of the same data type itself. In Python, it can be of any data type you want. Alright, now suppose I have a very long list and I want to find the length of the list. What I do is L is equal to, let's say, create anything. If I have this list, to find the length of this, I do len of and then bracket open and the name of the list. I get 4. 1, 2, 3, 4. There are 4 separate elements separated by a comma. Alright. Now, there is another way to make a list other than use these square brackets, which is to write list bracket open, and now I can put in whatever I want. However, I have to put the double round brackets. I have to put 2 round brackets and then I can put whatever I want. Same thing, hello, A, B, whatever. Same thing is going to happen. I get 3 in this case because I have only 3 over here. Alright. Now, there's something called indexing in lists. What indexing does is, it tells Python that hey, I have a list. I'll just make it easier, I'll write it in square brackets for myself. 5, 10, 15, 20. Now Python is told that each element in a list is represented by an index, because if I wanted to access a specific element of the list, what am I supposed to do? That is what indexing is used for. Indexing specifically takes each element and then can return it. To find out how to do indexing, I type the name of the list, which is L in this case. Now I open the square brackets right next to L, and now I write the index at which it is. Index at which it is simply says at what position is the list at, -1. That means 5 is at the first position, -1 gives me 0. That means this is at element 0, 5 is at element 0, element 1 will give me 10, element 2 will give me 15, element 3 will give me 20. This is how I do indexing of a list. If you notice, every list is not going to start from the first position, but it is going to start from 0. This is 0, 1, 2, 3, 4, 5, 6, and so on and so forth. However, remember that it always starts from a 0 and not from a 1. So I get 5, 10, 15, 20. If I remove this, I will get 10, 15, 20 because as I said, it starts from a 0. I'm not asking 0th position to come at. I'm not asking the element of 0 to be printed. I'm asking the element at 1 to be printed, which is 10. So 10 is printed, then 15 is printed, which is element at 2, then element at 3 is printed, which is 20. This is how indexing works in Python. However, in Python, you also have negative indexing. What is negative indexing? If I don't want to keep on counting how many items do I have in a list, and or if I want to do length minus 1 and that becomes a huge headache, what I can do is, if I want to get the last element or elements from the last half, what I can do is I can write L of minus 1. L of minus 1 gives me the last value always. Minus 2 is going to give me the second last. Minus 3 is going to give me the third last. Now you may be asking, why doesn't negative index start from a 0? If negative index started from a 0, then the compiler would be confused whether I'm asking this position or this position. And negative 0 and 0, there is no difference in them. So the compiler will get very confused. So negative indexing always starts from minus 1 instead of 0. Now there is something called a range of indexes. Now suppose if instead of writing L of 0, L of 1, L of 2, L of 3, L of 4, all the way to L of 5, if I run this, I get 5, 10, 15, 20, 25, 30. Instead of doing this entire thing, what I can do is I open my square brackets, I write 0, 2, 6. I write 0 to 6. I get the same exact thing but in a list form, which is acceptable. Now you might be asking, why do I write 0 to 6 and not to 0 to 5? If I write 0 to 5 and I do the same thing with these indexes, I'll just show it to you here. 0 to 5, because I only iterate to 0 to 5 over here. I get till 30 over here and I get till 25 over here. Why? Because what does the range of index does is, the first value that it takes is inclusive, but after the colon, the second value is always non-inclusive. That means it is excludable. That means the position at 5th is excludable. That's why I took it at 6 in the first try. Now something else you can also do is, instead of writing 5 or 6 over here, what I can do is I can refer it to its negative index, which is 0, 1. If I start from the negative, it is minus 1 and then minus 2. This will also work the same way and it's going to give me till 25. Why? Minus 1, minus 2. This is not inclusive. The minus 2 is not going to be included and it takes this entire thing. So if I put it at minus 1, even 30 is going to be included because minus 1 stops over here. Now the next thing that comes in the range is, if I leave it, if I start from 2 over here, I write a colon and then I put nothing over here. Normally what happens is I would put 6 or 7 or 8 or whatever. If I put nothing over here, this tells Python that I want to start from the second index and I want to end at the last index. That means everything that is there till the last index is going to be printed over here. It starts from 15, which is the second index, first 0, 1, 2, second index, and it goes till the end, which is till 35. Now, same thing can happen, but I leave this blank and I say -1 over here, which means I start from the very beginning, I go till the last one, but this one is excludable, so it's going to give me 5 to 30 in multiples of 5. Now, suppose if I want all the odd indexes over here, I don't want 0 since 0 is even. I want 1, I want 3, I want 5. I don't want anything else. So what I tell Python is, I want to skip every other index. So I tell Python, I have to start from a 1, because I start from 1, I don't start from 0, and I skip something till the end. So this one is left blank, nothing happens to it. Another colon is put and I put 2 over here, which means I start at index 1, I go till the extreme end, and I put a step of 2. That means I'm going to skip this, I'm going to do this, I'm going to skip this, and I'm going to get this one. How does this come is because a step of 2 simply means that from 1 it will add 2 instead of adding 1 to its index. Normally if it adds 1 to its index, it will give me a 3 in the range, but in the range now it's giving me a addition of 2. Normally what happens is that it goes from index 1 to index 2 to index 3 to 4 to 5 to 6. Over here it's going from 1, it's adding 2 instead of adding 1, which makes it 3, which makes it an addition of 3 to 2 gives you a 5. Let's just say I have some duplicates over here, 5, 5, 5, 5, 10, 10, 10, 10, and 20, 20. Now I want to count the number of duplicates in my program. What I do is I simply write L dot count and then I enter whatever I want. Let's say 5. Over here it's going to give me the number of duplicates, which are 5 duplicates. Let's just count it: 5, 1, 2, 3, 4, and 5. If I make it 10, I also have 5 duplicates, which is first, second, third, fourth, fifth. 20, I have 3, the first, the second, and the third. Now suppose instead of duplicates, I want to find out the index at which it is. This is simple searching. You can also do it using a for loop, but in a list it becomes pretty easy in Python by simply writing L dot index, and then I write this is going to print out the first occurrence of whatever I write over here. Let's say 5. It's going to give me 0 because at index 0, remember this starts from 0, at index 0 the first occurrence of 5 is available. It gives me 0. 35 gives me 6. 0, 1, 2, 3, 4, 5, 6. Alright, but now what if I enter something that isn't there at all? Let's say 4, which isn't there in the index at all. It's going to give me an error out here. So just remember that. Now suppose if I want to change a list, I'm using the same list. If I want to change the list, what do? Is I want to change, let's say, list of 4. Instead of 25, I want it as this is not 25, and I print L. I get 5, 10, 15, 20. This is not 25, 30, 35, and whatever. The same thing can be done. Instead of just using 1, I can use a list of ranges. Let's say nothing to 4, which means that I have to provide from 0 to 1 to 2 to 3, which is 5, 10, 15, 20. which is 1, 2, 3, 4. 4 I have to provide. Not 5, not 10, not 15, not 20. Not 5, not 10, not 15, not 20, 25, 30, 35, 40, whatever. Alright. Now, if I exceed the value, if I write not 35 as well, which isn't included, I will get an extra not 35 and everything is going to go as planned. Nothing is going to be cut. What happens is that Python just adds an extra index to the entire list. However, if I undercut, if I give what is less than required, Python will simply cut down all the rest of the indexes and just replace all of them by just this thing. Now to this list, this original list, if I want to add something, what we have already done is changing something. Now I want to add something. What I do is l dot append not here. Not here is going to be appended to the end of the list. That means after the last 20. Everything and then not here. The insert method also does the same thing, except that with the insert method requires two parameters. First parameter, the index at which it wants to be inserted, and the second parameter, whatever I want to insert it as. Let's say 5 and then hello. That means at index 5 it's going to be hello, and whatever was previously at index 5 is going to be shifted to 6 and onwards. What was at index 5? 30, I think. So now 30 is going to be at index 6. If I just do index of 30 over here, you'll come to know. I get 6 out here, which was earlier 5. If I do this, L dot index 30 out here is going to give me 5. After I insert this at 5, it's going to shift and it's going to go to 6. You will just come to know in a minute. 5, 10, 15, 20, 25, 30, which was originally over there, is shifted now and hello has been inserted out there. Now another method that can be used with this is the extend method. If I have two lists, this being the first one being L and the second one being L2, what I can do is I want to add them into one single list. How do I do that? Pretty easy. Print. What I do is L dot extend L2. That's it. I'm done. And I print L. This is going to be added to the end of the list using the extend method. I cannot insert it anywhere I want. Now we have learned about insertion, we have learned about extension, we have learned about appendation, and we have learned about changing. Now what we are going to learn about, which is left, is the removal. If I want to remove anything, I can use the remove method. L dot remove. Now with this remove, I can write whatever object I want. Let's say 20. In this list, it removes the first 20 that it sees. Remember, it will remove the first 20 that it sees. A similar way of doing this is using the pop method, but the pop method removes the index. So if I want to remove index 3, I remove index 3, which was coincidentally 20, and the same list is going to be printed out. Another way to do this same thing, deletion, is using the del keyword. The del keyword can always be used to delete anything, and the entire list size is going to be changed. If I change list 4 right now, I get 20 back, but my 25 has been deleted completely. I can also delete an entire list. I del L, but I can't print the list because obviously it has been deleted, so I can't print it. So it's going to give me an error out here. But right now this list has also been deleted, as you saw, because of the error. So we are done with deletion. One more thing is left, is the clearance. I can clear the entire list, and if I print it, it's going to give me an empty list because the entire thing was cleared, nothing was left. The last thing in lists that we are going to do, since we've already done searching, simple searching in lists, the next thing that we're going to do is sorting in ascending and in descending order. If I wanted in ascending order, I simply write L dot sort and I print it. My bad, first I have, if I want to sort it, what I do L dot sort and then I print L. I get 5, I get all the 5s first, then the 10s, and then the 15, and then the 20, 25, 30, 35. This is sorted in simple order. Now if I want it in descending order, what I simply do is I write reverse is equal to true. By default reverse is false, that's why it gives me ascending order. Right now reverse is true, so it will give me descending order, 35 all down to 5. That's all for lists. Thank you.